everybody, we're back and we are continuing our conversation about congruent triangles. So remember back to the other lesson when we talked about CPTC, and our important sort of if-then statement was, if we know that two triangles are congruent, then we know that all of their corresponding parts are congruent. So if two triangles are congruent, then we know CPCTC. You know it, you love it, you've internalized it, you've practiced it. So now we're going to talk about the converse. So before it was if two triangles are congruent, then CPCTC. So the converse of that would be if CPCTC, then triangle ABC is congruent to triangle DEF. So if I can prove AB is congruent to DE, BC is congruent to EF, AC is congruent to DF, and angle A is congruent to angle B is congruent to E, and C is congruent to F. If I can prove that all of those corresponding parts are congruent, then I know that those two triangles are congruent. But I'm an old lady, and I gotta tell you, life is short. Hopefully my life is very long, but time is ticking and I don't have time to check and see if 6 pairs of corresponding parts are all congruent to each other. So we have these awesome congruence postulates that are little shortcuts and tell us if two triangles are congruent to each other much faster. And that's what we're going to talk about today. So we're going to talk about triangle congruence postulates. And if you have a second, you can go on to this NCTM website. It's illuminations.nctm.org. You can put in this exact link if you'd like, or you can just search triangle congruence postulates on that website. And it's really cool. It's like a cool way to kind of mess around with what we're about to talk about. So the first of our congruence postulates is this one. So here are the things I'm given. I'm given that AB is congruent to DE. I'm given that BC is congruent to EF. And I'm told that AC is congruent to DF. So is this enough information to tell me that I've got two congruent triangles? Well, let's see. I'm going to pull these parameters out like this and try to make a new triangle with them. And I did. There is literally no other way for me to make another triangle with those parameters. So lo and behold, if I know that all of the corresponding sides are congruent to each other, then I know that these two triangles are congruent. We don't care about the angles. I mean, we do. We love you angles, but it didn't matter what the angles were because we knew that the 3 sides were congruent to each other were great. So this is what we call the side congruence postulate. We abbreviate it SSS, the side congruence postulate. And this tells us that we've got two triangles that are congruent to each other because all 3 of their corresponding sides are congruent. So that is postulate number 1. Postulate number 2, here we go. So I am told that AB and DE are congruent, and I'm told that AC and DF are congruent. And then this is really important. I'm told that angle A is congruent to angle D. That's what we call the included angle. See how the included angle is essentially like the vertex angle, like where those 2 sides that we have information about, where they meet? I could have angle B and angle E be congruent to each other, but because that's not the included side, because that's not the included angle, we actually don't care about those. So it has to be the included angle. So given these parameters, look what happens here. So I've got my side, I've got my angle, and I've got my side. Boop-a, 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 boop-a. See how I've just created another triangle that is the exact same as those other ones. So given those parameters, there's literally only one one triangle that I can make. So this is another congruence postulate, and this is what we call the side, angle, side congruence postulate. Side, angle, side. So that's our second one. All right, and our third one, this is what we call, I'm actually not going to give you the name yet. All right, so let's go through this. Here's what I'm told. I'm told that angle A and angle D are congruent. I'm told that line segment AB and line segment DE are congruent. And I'm told that angle B and angle E are congruent to each other. Now, remember how we talked about included angles before? Now, do you see how AB and DE are included sides? That's because they're sandwiched between those 2 angles. I could talk about EC here and EF, but because those are not included, so see how like BC is not made up of the two angles that we're talking about, then we wouldn't consider this the same postulate. So given these parameters, and I'm going to drag this guy boop, 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 over here. So given these parameters, I'm going to try to make a new triangle. So I'm going to go duka, 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 bring this guy out and bring this guy out. I made the exact same triangle that I had before. So given these parameters, we now know that those two triangles are going to be congruent to each other. Again, we only had to deal with 3 of those corresponding parts, not all 6. And this is what we lovingly refer to as the angle, side, angle congruence postulate, or ASA. So remember, we've got side, side, side. We've got side, angle, side, a little sass right in there. And then a little ASA, angle, side, angle. Now you might be thinking to yourself, wait a second, there are other combinations here of corresponding parts that we haven't talked about. So let's talk about them. So here's the first one. So what about an angle, angle, side situation? So I know that I've got corresponding angles and another pair of corresponding angles and then that side. So this would be a situation where it's not the included side. So let me see what I've got here. So I'm going to pull down these parameters. This guy got twisted a little bit. There we go. I'll find him out. And then here is my other parameter. Boom. Now let's see. Is there any way with these parameters, is there any way that I can make a triangle that looks different than the one up above? Shoot, no. So guess what? This is a very exciting day. The angle, angle, side congruence postulate is a thing. Because look, I've got my 2 angles that are congruent to each other. I've got my other angle right here. Those guys are congruent to each other. And then I've got this last side. We talked quickly in class about something called the no choice theorem. Remember, the no choice theorem said, if I have 2 angles within 2 triangles that are congruent to each other, so like this guy, this guy, this guy, this guy, let's say that this is 100 degrees. We know this is 100. This is 50, let's say, use your imagination. This is 50. We have no choice. Both of these top angles have to be 30 degrees. So I know that this guy has to be this guy. So what winds up happening with angle, angle, side is it actually winds up being an angle, side, angle situation. So angle, angle, side, yes, you are a congruence postulate. So remember, we've got side, 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 angle, side, angle, and now angle, angle, side. Now let's try this other one. Let's try the side, side, angle. All right. So in side, side, angle, I've got, excuse me. So in side, side, angle, I've got 2 sides that are congruent to each other, and then this one angle. So if I keep it like this, look, there's only one way that I can create a triangle, but I have no restrictions here with this vertex angle. So like this vertex angle and this vertex angle don't have to be the same. So watch what happens, and obviously, be a little lenient here. But what if I took this and I swung it like this? What? Do you see how that vertex angle got a lot smaller? But the side length, and again, be gentle here, but this side length winds up being the same. So this side and this side are still congruent to each other. This side and this side are still congruent to each other. And this angle and this angle are still congruent to each other. But I just created a totally different triangle. And so the side-side angle postulate is not thing. And the way you can remember this is you would never say this word if it were spelled backwards in school. Never! Terrible. All right, last one, angle, angle, angle. Is this a thing? So let's see. So I've got 2 triangles whose all their corresponding angles are congruent to each other. So I'm going to try to make a triangle that looks a little different than the one up above. And let's see here. Oh, wait, I did it. It's a teeny tiny triangle, but look, all the corresponding angles are still congruent, see? So I've got this vertex angle is still congruent to that vertex angle. This guy is congruent to this guy, and this guy is congruent to that one. And so the angle, angle, angle thing is not a thing. So this is not a congruence postulate. And in fact, for angle, 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 those would be similar to each other, most likely. Not all the time. But and so that's why they can't necessarily be congruent. They could be congruent, but not necessarily. All right. So last one. What about what happens in right triangles? So I said that side-side angle was not a thing, right? Because you would never walk around saying the word A, S, S. Ah! So side-side angle is not a thing, but there is one way that it's a thing. In right triangles, watch what happens. If I know that this side is congruent to this side, and this side is congruent to this side, what do we know about right triangles that is like an association with side lengths that we don't know in other triangles? The Pythagorean theorem, right? I have a squared plus b squared equals c squared. So look, let's call this like d, e, and f. If a squared plus b squared equals c squared, then I know d squared plus e squared equals f squared. If e and f are the same as b and c, that means a and d have to be congruent. So side-side angle actually does exist only for right triangles. And we call this lovingly wonderful congruence postulate, we call it this. We call it HL, and that stands for hypotenuse leg. So we don't call this side-side angle in a right triangle. We call it hypotenuse leg, HL. All right, so that is all of our congruence postulates. So remember, we started off with side, side, side. Then we got a little sassy. Then we did a little ASA. And then we did angle, angle side. And then we ended with HL. You should feel super comfortable with these. Again, we're going to practice a ton in class. So you're going to get more and more comfortable to recognizing them. So the last little challenge, I want you just to try this. Try to do this proof. Pause the video and then we're going to come back. All right, if you had no idea how to do this, that is totally fine, but I just wanted you to try. So you had all of your given information first, obviously, so easy. And then we know that angle D and angle F are both right because we shook out our givens, right? That's the definition of perpendicular lines. And then we knew that angle D and angle F had to be congruent because all right angles are congruent. Then watch this. So look what I'm given here. I'm given that AD and BF are congruent, and I'm given that DG and FE are congruent. I'm also told that these guys are congruent to each other. So if I were to write this down, see how I've got a side, an angle, and another side? Those two triangles are congruent because of SAS. Woo woo! And then the last thing, if I know that these two triangles are congruent to each other, why do you think that angle A and angle B are congruent? They're congruent because of, and we're going to use this a lot, CPCTC. Woohoo! So go ahead, tackle the homework. Again, if this last slide was tough, don't worry. We're going to do a ton of this moving forward. This is just a little challenge. So I will see you soon. Thanks so much for watching.